Okay, good morning. Today we are starting our last section in chapter 5, which is inverse trig functions. So you know what inverse functions mean in chapter 4.1. You remember our currency exchange question, like you go to Europe, you need to change dollar to euro, and then when you come back you need the inverse change rate, a function. So we found an inverse function, but to be able to find inverse functions though, there is one requirement. Not all functions have inverses. What was that requirement in 4.1? Not every function is invertible. To find backwards function, a function needs to be, come on, what is the key requirement? Horizontal line test. What does horizontal line test do? Nobody remembers? One-to-one, yeah. The function must be one-to-one so we can invert it. So just keep that in mind. We are going to look for inverse trigonometric functions to our 6 functions: sine, cosine, tangent, etc. Cosecant, cotangent, secant. But to invert them, they need to be one-to-one. Okay? Well, before going into deeper into each function, why don't we take a look at why do we need that? Why do we need to find inverses? I mean, from change the dollar to euro, we know the need. You need your money back so you can spend, right? But here it pops up. Usually one of the common applications is geometric applications, like a triangle formed when a sunlight hits what is this? A pole, what kind of yardstick. So there is a yardstick or traffic lamp or whatever you call a tree. It casts a shade. This is the shade. This is the height of the object. And let's say this is the shade. 1 foot long or 1 yard long object creates 4 foot long shade. Okay? So these two are, you can measure. You go climb up and measure this stick. You go and measure with a ruler or something the shade. I don't think you can measure the hypotenuse, but you can compute it, right? It's a triangle, but I'm not sure you know it. Question is, what angle this sunlight was hitting this yardstick? What is the angle the sunlight makes with the ground or makes with the yardstick here? Same angles. We are gonna measure that theta, and we know that this theta adjacent side, this is the adjacent side to theta, this is the opposite side, forms a trig function relation between these 3 objects. Theta, 4 feet and 1 yard or 3 feet, forms a relation, and that relation is tangent. Or actually you can also build cotangent. Isn't tangent opposite over adjacent? Same way you can call cotangent theta is adjacent over opposite is 4/3. But you can build this equation. This is the definition of tangent in a right triangle. Well, question is, I don't know this. I'm looking for theta. So theta is under tangent. I know its value under tangent. How can I get back to theta? Alright? Usually, so far in this chapter, this is what we did. I have provided you the data, theta. This is given to you, this part, such as I give you pi over 4, and you gave me the answer by a calculator. You put this in a calculator from the table or from the ring wheel of values. You gave me this value as 1, for example. I provided this side, you gave me that side. I provided this side, you gave me that side all the time. Question now is, I'm giving you the value of the function. How do you give me the input value or x value or theta value? So to be able to get theta value, you need to move tangent away from this to other side. So tangent theta was 3/4. I need to get theta alone, and I wonder how we do that. you do that, you're looking for the input values, range and domain values replaced if and only if you have an inverse function takes this output value and use it to compute the input value. So we are inverting the roles of input and output. We are looking for input using the output. That requires the use of an inverse function. The only way you can compute this angle is using an inverse function. So we need to build one. I actually already gave you that. We call it tangent inverse. It exists, but there are some requirements we need to mention. Okay? So this problem is just a good proof of why we need inverse functions, because not always you're given the angle, sometimes you're asked for it. So you need to invert functions and use inverse function to compute that. So tangent inverse 3/4 will give us, and computing this easy, all you need to do is everybody must have this inverse functions in scientific calculators, or even Google does that, but we have a different name for it. Arctangent is what we call it, for example, for this problem, and you can compute it as the radian. So this is one way to call it tangent inverse, but another name for this is arctan. Arctan means inverse of tangent. Okay? So you either use this notation, but I like kind of this better, because most people confuse this -1 exponent as reciprocal of tangent. It doesn't mean reciprocal. This is inverse. So rather than power, I like this a little bit better. You can also type this in Google and it will give you the answer. But I don't think you can type in raised to the power -1 and compute that. Let's check anyways. Such as it won't understand this, I think. Power -1 3/4. Does it do that? No, it can't. Okay, but it understands arctan. So for typing purposes in a software other than your calculator, arctan is slightly better. Anyhow, let's build all those inverse functions for each and every 6 trig functions you know: sine, cosine, tangent, cotangent, cosecant, secant. Okay? We start with the first one. What is this one called? What does this picture belong to? Which one? Sine. This is the picture of sine, or more detailed here, more focused on here. But there is a problem. What's the problem with this picture? There is an issue. Can you get the inverse of the pictured function here? Can you get inverse of this thing? Why? We cannot find inverse of this function presented here. I called it sine, and I'm telling you that you cannot find the inverse of sine. Wait a minute, we have arcsine, sine inverse in all our calculators. How did they find it then, if it's impossible? This is why impossible, because this function is not one-to-one. For a single, for example, value 1/2, there are multiple angles, actually infinitely many angles, making value 1/2 when you insert those angles into sine. Okay? Such as sine 30 is 1/2. Sine 150 is 1/2. Sine 390 is 1/2. You can add 360 and get millions of such values. It's not one-to-one. So guess what they did? Instead of this long wavy object, they took a pair of scissors and cut it out. They cut the picture into a perfect range of one-to-one values. Look, when I cross these with horizontal lines now, how many times I'm touching it? Only once at every moment, right? Even on the top it's once, or bottom. Agree? So when you see inverse sine notation or somebody inverting sine, you can only compute values from -π/2 to π/2. Very important. When I ask you what is inverse sine of such and such value, don't tell me it's 3π/2 or 300 or 190. Impossible. The value you must be giving me is between -90 and positive 90. Oh, they picked this little piece of line, curve, could have been taken this one. Could you take this part as well? Yeah, you could have taken this value, but your angles are too big here. So we go with the minimal, smallest angles that represent entire range of y values. So this is the best choice they went with. It was their choice. Whoever first figured this inverses out, they went with this, and it's the most reasonable one. I mean, these are big angles or two small angles, two negative angles. They don't make sense. Or you could have picked this side as well. This is also good representative of 1-to-1 range. But it's still between 90 and 270, still kind of big angles. Alright? So sine is cut, and we only invert this part. Well, what is the inverse of it? Picture of the inverse. This is the picture. Remember, inverse of a function as a graph reflected along y equal x line. So you reflect this blue picture along y equal x, and you get this red picture. This is the picture of sine inverse. Okay? So I don't want you to memorize all inverse function pictures, but just know, in case you need it in future, just know that it's just reflection of sine. You already will know sine and cosine graphs. So just take them, reflect them, and build it from scratch. Okay? But it's better if you, of course, know it, but I don't require you to guys memorize these pictures. Always know how to construct them when you need to. Alright? So sine is this. It's a little bit stretched looking because they took extended range here. They just rescaled it into wider domain, but it's the same. Alright, is sine inverse clear? Alright. Oh, here are the details I mentioned again. Inverse function, sine inverse function, is denoted by sine inverse. We're just summarizing everything we said on a proper way. Or we denote it by ARC sign, arc sign. Either one of these notations may be present in the question. Is the inverse of sine, however, it's only restricted to domain angles between minus 90 and 90. When I ask you a question like this, you can never give me an angle more than 90, smaller than minus 90, okay? And in radians, everything should be in radians. Don't give me degree values, not 90, but pi over 2. Okay? And we already know sine values are already between minus 1 and 1. Okay? Inverting means flipping x and y locations. So if somebody asks you to compute sine inverse of a value, this will be given and you will be asked to figure out this value. You may need to switch to sine by flipping these two values. Put y inside sine and x outside on the other side of the equation and change it into regular sine, and then compute y. You still need to compute y, so you will need to play a guessing game. What value of sine becomes x? For what angle it becomes x? So this will be given to you, and this will be asked, and you will figure it out that way. If it's a number value, you can find out by a wheel. Otherwise, you need to use a calculator. So again, avoid using calculators here. I know your calculator can do this. I can put this arc sine root 2 over 2 into Google, and they give me the answer. But we need to do this. You need to learn this doing by hand if the value is on this wheel. Remember, this wheel is to assist you figure out some common sine and cosine, sine, cosine, tangent, cotangent. Any one of the 6 trig functions you need to know, you use this wheel. Remember? Actually, if you memorize the first quadrant, you can get the second, third, and fourth quadrant by checking the sine table. But If you know whole wheel, it's great. Alright, so how do I find this by hand without a calculator? Is they're asking me this value, right? Let's call it y, or you can call it x or theta, anything you wish. This label is up to you. I call it y. And to be able to find this out, I will first flip this. So y will go to the right, root 2 over 2 will come to the left, but I'm sorry, root 2 over 2 to the right, y to the left. But arc sign, when you change domain and range, you interchange them, arc sign turns into regular sign. So this equation and bottom equation are the same. What angles under sign makes root 2 over 2, and saying what is arc sine root 2 over 2 is the same. This is an angle you need to find. This is the value. Now the value went to the right, angle is to the right. Value to the right, angle is to the left. Okay, now take a look at the wheel and which angle under sine give us root 2 over 2. So sine means in the wheel x coordinates. No, it's y coordinates, right? Sorry. Y coordinates. So you need to find an angle whose y coordinate is root 2 over 2. I scan all entire wheel and I see a point here and I see a point there whose y coordinates are root 2 over 2. Both root 2 over 2. But which angle is our answer here? Which one? Is it 45 or pi over 4? Or is it all the way across? This is 3 pi over 4. Both have, when you put both pi over 4 and 3 pi over 4 into sine, both gives you root 2 over 2. So which one? 3 pi over 4? Why? What is wrong with 3 pi over 4? Sine is root 2 over 2. It's over 90. Again, arc sine values are only limited to minus 90 pi over 2 to positive pi over 2, positive 90. Okay? So you can only pick the values from this side of the wheel for sine computations, arc sine computations. Minus 90 to positive 90. Ignore the left side. So the right answer is not 3 pi over 4, but is pi over 4. Okay? So we will go ahead and enter here pi over 4. Alright, we will just do this for the other two questions. Same deal. Alright, let's call this time theta. I don't want to call it y all the time, theta, because it's an angle and we like using theta for angles. And I need you to, right underneath, change this into sine equation. Sine theta equals 3 pi. I'm flipping these two and making sine inverse into sine. Alright, tell me, on this wheel, and especially on the right side, on this range, which angle stops at a point whose y coordinate is 3 pi, about 9 point something? Yeah, which one? Which one do you see 3 pi? Is this 3 pi? No. Is this 3 pi? No. Is this 3 pi? No. 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 Or is there something in between? Maybe 15 degree? 42.5 degrees? What's the verdict here? Can any point here, whenever you stop on this wheel, can it have a y value? This is roughly 9.46 something. Can any point here, look at their y values, exceed 1, the maximum these y values can become is 1, right? Do you all agree? Isn't sine actually between -1 and 1 oscillating? Between 1 and -1? It can never go beyond 1. How can this sine become 9.46? So what is the final conclusion here? Undefined. You cannot compute this function. Domain of sine inverse is between minus pi over 2 to pi over 2. If you see an angle outside of this range, I'm sorry. It's between, domain of sine inverse is between -1 and 1. If you see a value outside of this, 3p is like 9 point something, go ahead and say this thing is undefined. It's not, the value provided here is not in the domain. Again, what is the domain of sine inverse? -1 to 1. Look, here is the picture of it. Red picture. It only works from -1 to 1. Outside, you have clueless. You have no clue, okay? So that was 2. How about number 3? So arc sine √3 over 2. Any ideas? Is this undefined as well? Is there a value, theta, that can make √3 over 2 on this side of the wheel? Which one? Yes, 60 degree, pi over 3 as √3 over 2. That's it. These questions are 10 seconds questions if you know your table of values. Alright, well, we don't have just inverse of sine. Every 6 trig function have inverses. So we will quickly take a look at their inverses. And most importantly, what is the restricted part? What part is cut out and used? It's important. For cosine, you see it's not negative pi over 2 to pi over 2. It's not -90 to 90. It is 0 to 180. 0 to 180. And look, when you invert this, like inverse of it, it's a strange shape like this. Because this part goes down, this part goes up here, and it makes this shape inverse. Again, domain of cosine inverse is between -1 and 1 again. You can never exceed -1 and 1. Look, it's between -1 and 1. This red shape. But the range is, or what cosine values can attain, is from 0 to pi. 0 to pi. When I ask you, give you a value between -1 and 1 and ask you cosine inverse, the answer you give me can never be beyond 0 or pi. It must be something, an angle you must be providing between 0 and pi. Okay? So this time you are taking a look at the upper part of the wheel. The answers you must be picking from the upper part of the wheel. 0 to 180. Okay? For cosine. Sine, -90 to +90. Cosine, 0 to 180. Arc cosine. Okay, how about tangent? For tangent, we pick this right the middle piece for 1-to-1 piece, restricted domain. And it's the same as sine. So sine inverse and tangent inverse has same range values. Okay? The value, when I give you a number inside, the result, angle result you're gonna give me must be between -90 and +90. Sine and tangent are the same. Cosine and cotangent are the same as well. Okay? And here is the picture of tangent inverse. Just invert, flip the blue picture, this middle one. Alright, this table gives you the summary of all three we have investigated so far. All three are here. Nothing new with the pictures. Okay? So everything we mentioned this morning is already been tabled here. Whenever you need to check something, go refer to this table. Again, sine inverse values are between minus 90, positive 90. Cosine is 0, 180. Tangent is minus 90, positive 90. Alright, let's do some mixed exercises. There are two cosine inverse values, one tangent. Again, cosine inverse. All these are manual work. Don't use your calculators. All the time you're presented something like this, flip domain and range values. Cosine theta equals 0. What angle has a terminal point on this wheel, a point on this wheel whose x coordinate, cosine values means x coordinate. Find the points here whose x coordinate is 0. Which two angles can you find on this wheel whose x coordinate is 0?
90 and 270.
Yes, it's these two. So we need to pick one. Which is the right answer? Is theta pi over 2 or 3 pi over 2? Which one? Pi over 2. Because when it comes to deciding cosine inverse values, we consider the upper half of the wheel. It needs to be 1 to 1. You need to come up with a single unique answer. Okay? How about the second one? This is a 2-second question. Undefined. Why? I flip this, cosine theta equals minus 8. Can cosine or x coordinate of any point be beyond negative 1 and 1? No. On a unit circle, all the coordinates are limited between minus 1 and 1. Minus 8 is undefined. Alright, tangent theta, I call this theta. Tangent theta equals 1, and tangent is the ratio of sine and cosine. That means y value over x value. You are going to find a point here. Their ratio of y and x value must be 1. Which points? Again, this is tangent inverse is between, tan inverse is always between minus 90 and positive 90. So I need you to focus on to the right side of the wheel. On this region, tangent is the same as sine. On this part, which point has y coordinate versus x coordinate ratio is 1? Is it this? No, this is 0 over 1. No. 1 over 2 over root 3 over 2. When you take a ratio, it's not this one. Is it this? No. Is it that? So what is the right pair whose ratio will cancel out to 1? What is it? Which angle here has x and y values matching so they can cancel to 1? Which one? Pi over 4. It's this one, look. X over y, tangent pi over 4 is 1. Or you could just say this from the table if you know the table of tangent values. Make sense? This is pi over 4. Again, I know it's very tempting to use a calculator here. Don't. Alright? So was the answer here? This was pi over 2. Don't use a calculator again. Alright. But sometimes, yeah, you are obligated to use a calculator, such as, for example, if you have a decimal value which cannot be figured out on the wheel. Yeah, here you need to use a calculator, okay? Because there is no way I can figure out what angle under tangent makes 0.8 or 8 over 10 or 4/5. I have no clue. Okay. Alright, now we are going to take a look at what happens when an inverse function, an original function that you inverted from, comes together, composed each other. And of course, an inverse function and the function itself automatically cancels out, and what's left out is x. If there is a big if. There is a big if. This is not always true. If the number inserted here is within the recommended range, such as for sine inverse x, that number must be -1 and 1. For example, what do you think here, guys? Oh, we always cancel. These cancel and get 2. Is that correct? Is this correct? This is wrong. Why? Because just answer this, guys. What is sine inverse 2? Let's call this theta. I want you to find out what sine inverse 2 will be. We don't know it. I call it theta. And I flip the sides. I get sine theta equals to what angle under sine gives you theta? This is undefined. Theta is undefined. There is no such value making sine to be beyond 1. So this thing is undefined. How can I compute sine of undefined as 2? Impossible. So first thing you need to check is whether this given angle or number is in the recommended range, which is -1 and 1. If it makes sense, if you can compute sine inverse of it. As a matter of fact, please don't memorize this. Don't. Do these questions, each and every question, one by one. Start inside, out. First do inside, then out. One by one, the way I showed you here. That's why I ask you to not use a calculator. Because if you use a calculator, you won't be able to figure out these questions. Okay? Because your calculator won't give a whole answer in this one, and when you compute its cosine, you'll probably get a rounding answer, close by answer, not exact. Connect math is gonna give you a false alert. Okay? Although you're doing everything right. So don't use a calculator. We'll do hand calculations. I covered this. This is just a good cheat sheet if you want to save time. That says everything cancels, but in the background it may do more harm if you memorize, oh, everything will cancel, we'll always get x. Yes, most of the time you will get this number, but sometimes you may get undefined or different numbers. See this one, for example. Very first example is a surprising one. Look, it says find arcsine of sine of 7 pi over 4. So you need to first complete this. Really, cut it out with scissors, take it to a separate page, and compute this blue box, please. And replace it. Replace, find and replace. Find this part and replace. Can you guys find me sine 7 pi over 4? Well, where is the 7 pi over 4? This is negative pi over 4. Or from the wheel, 7 pi over 4 is is this guy, right? So it is, which one is it? This angle. It's 315 degree, and its sine value is minus root 2 over 2. But again, if you want, you subtract 2 pi from it, and it's equal to negative pi over 4. And sine negative pi over 4 is the same as minus sine pi over 4. Sine pi over 4 is root 2 over 2. It's minus root 2 over 2. Alright. Find any way you want. Wheel, reference angle, or add a period, subtract a period from it. Use another table, but get this done. And I know, we know, it's minus root 2 over 2. Okay? Alright, we got that part right. Sure. Then what do we have next? This is arcsine of this blue box must be replaced by that value you found, minus root 2 over 2. Okay? Now take this wheel and figure out what angle, what theta angles under sine gives you minus root 2 over 2. Alright, let's take a look. So again, here is what I do. I call this theta, and I'm looking for this theta. That means I need to replace these and figure out what angle substituted in sine gives you minus root 2 over 2. I'm gonna find it and call it. That's it. Question is over. So tell me, which point on this wheel has y coordinate? This is y coordinate of that point. Has negative root 2 over 2, which is this same point, right? Correct? So it's 7 pi over 4. Oh, it turned out to be these two are cancelling. Is that right? 7 pi over 4. Oh my god, it's incorrect. How come? The theory says, the formula says they do cancel. I canceled them, or here actually. Arc sine is this one. Arc 1, this one. They cancel, and we are supposed to get this x out. 7 pi over 4, and I verified it 7 pi over 4 from the wheel. What is wrong? No, it's not over 1. What do you mean by over 1? This is not over 1. Minus root 2 over 2 is a value between minus 1 and 1. That's not it. You're forgetting what? What are we forgetting? Arc sine, results of arc sine is limited to what? Yeah, minus pi over 2 to pi over 2. Just because you found this value on the wheel, yes you did, but you can't take this raw value. This is uncooked value. You need to think this on the right side of the wheel. You need to convert every angle you obtained here into negative angle, because arc sine works only from minus 90 to positive 90. So 7 pi over 4 is not gonna be accepted. So we need to change this into negative pi over 4. Okay? Let's try this. Yeah, there you go. Same angle, same result, but in the desired range, because sine inverse has a range of minus 90 to positive 90. So these questions are tricky. Simple looking. Oh, we just cancel, right? No, we don't just cancel. Alright, this one kind of easy, but I will still do it the ordinary way. First, work inside out. Compute this on a separate page. Cosine inverse negative 3/4. And for this, you may need a calculator, because on the wheel, do we have negative 3/4 on the wheel? A value like that? Cosine inverse negative 3/4 means you need to compute an angle whose cosine is 3/4 or 0.75. So we have 0.75 or 3/4. This is x coordinate. Do you have any x coordinate here reads 0.75? No, it's probably somewhere here. No, probably somewhere here, or maybe here, somewhere in this range. Probably almost here, almost around 45. Because root 2 over 2 is about 0.7. So we need to be somewhere here. Okay? Now, anyhow, whatever this angle is it in our desired range? Right? Is it from 0 to 180? Somewhere here, okay? But I put that angle into now cosine. So you're thinking this is 45-ish. Just keep in mind, you don't need the entire, take a calculator and compute this if you wish. Cosine inverse minus 3. It's not necessary. That's what I'm trying to prove. Okay? I know it's 45-ish, but I just want to do it anyways. Cosine 3/4, right? Is it the same? Yeah. It's in radians, so I want to change it into degree by multiplying by pi over 180. No, 180 over pi. I told you it's 45. It's like 41.4. Okay, it's in the neighborhood. 41.4. Put this 41.4 into cosine. What do you expect to get in the answer? So what is cosine 41.4 degree? So I need to take this angle back and put it cosine. What do you guys are gonna get? Oh, this is negative though. I picked the wrong one. So this is negative, right? I ignored that one. Yeah. So it's not positive 75, it's negative now. And I have a negative one. It's gonna be on the second quadrant. I think it's gonna be like 140 something. 138. 138.5 angle. Now I'm going to try this into cosine again. What is that cosine? This is 138-ish. What is cosine 138-ish? Well, take a look. 138-ish is going to have that same x value 0.75, negative 0.75. Right? Isn't it how I found this value? Negative point. I found it here, negative 0.75. And I thought, oh, this is almost 138, or it's more like here. But now I put it in cosine, I'm going back to 0.75. So what is the short story here? I just over-explained it maybe. If this value between -1 and 1, take out your color pen and cross these out, the answer is gonna be the same. Okay? So if this value is a secure value in the range, you don't have to worry about canceling it. It's gonna go back to the same value. Cosine inverse is gonna take it back to an angle, and that angle with cosine will be again carried to this number, negative 3/4. So that's it. Only this works cancellation is this number, cosine inverse value in the inside is between -1 and 1. If it is 2 or 5 or -5, we say undefined. Okay? This thing is -3/4. And See what's next. Well, what is different now? On this question, you're totally blank. You can't even use this chart, this table. This table is not gonna work because this table only explains what happens if same type inverse and regular trig function comes next to each other. Tan, 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 cos, 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 sine, sine. Matching. In our question now, we have a mismatch. Cosine and tan inverse. Oh my god. Or cosine and tangent inverse. Irrelevant things. Right? So how do we do these questions? Again, you may be tempted to use a calculator here, but please don't. We will again work inside out. Work inside out and compute tan inverse of -1 first. If you can, if possible. Alright, what is tan inverse of -1? We call it theta. And I flip this. What angle theta under tangent becomes -1? What is it? Alright, you have two options. You can use the wheel. -1 means, remember how we did +1? Y coordinate and X coordinate ratio must be the same so we can get +1, right? That's how we did it. To get the -1, tangent means Y coordinate over X coordinate. They must be opposite sign. And tangent only works on the right hand side of the wheel. So which point have the same X and Y coordinates with opposite signs? One, what's that again? 315 degrees. But we need to convert this into negative angle because tangent is between -90 and 90. So -pi/4. So this thing is -pi/4. So our cosine has -pi/4 inside. Now you need to compute cosine -pi/4. Well, here is -pi/4, find it. Right, this is -pi/4, -45. Cosine means x coordinate. What is the x coordinate of this value, this point? √2/2. Okay? Any questions? First, work inside. Find the angle, -pi/4, and now enter that -pi/2 to cosine, get √2/2. We need to start with this one then. What did I do? Oh yeah. Why did I put on the other spot? Okay. Alright, same deal. Start inside, compute this value by calling it theta. Well, this is an inverse function. I can't compute directly unless I'm using a calculator, so I flip it, flip the sides, make it tangent, use the wheel to figure out a tangent value. Tangent value means y coordinate versus x coordinate. So this is y over x. Is gonna give me root 3 over 2. So start dividing on again the right side, because tangent inverse gives you a value from minus 90 to 90, which y value and x value when you are dividing into each other becomes root 3 over 2. Which one? Positive root 3 over 2. So I believe it's not on this side, because one positive, one negative, when you divide them you get a negative value. This is a positive value, so your angle you're looking for is from 0 to 90, guys. Not here, it's here, because these are positives and I'm looking for a positive ratio. So which one gives you root 3 over 2? Anything? Anyone? Well, let's divide 1 over 2 root 3 over 2. I'm dividing the top one. I'm not doing this one because 1 over 0 is undefined. I need to do root 3 over 2 divide by 1 over 2. This gives you root 3. So tangent 60 is root 3. Wrong. This is 1. Wrong. This is 0. Wrong. So we have only one shot, or we need to go different method here. Wheel is not working. Well, I'm gonna do this. 1 over 2 divide by root 3 over 2. I flip and multiply, or you can cancel this. You don't have to flip multiply. You get 1 over root 3. I rationalize this, and I'm still not getting it. Root 3 over 3. And I'm not getting, oh, I'm sorry. It's not root 3 over 2. It's root 3 over 3. So we got it. I was gonna try a right triangle approach if this wasn't work, but it's easier than I expected. Okay, so it is 30 degrees, pi over 6. So this is pi over 6. Theta is pi over 6. How did I get it again? I just divided these two and I got pi over 6. This is theta. And we're not done yet. Cosine, we need to compute cosine of it. Cosine of pi over 6 is just the x coordinate, which is root 3 over 2. Probably I was thinking always the answer. Well, that's why I keep writing root 3 over 2 here. Okay. Any questions? Alright, here what was I was thinking, what if this was root 3 over 2? Really, if it was root 3 over 2, it's not on the wheel, then you can use the right triangle idea. Tangent means opposite over hypotenuse. Opposite is root 3. I'm sorry, opposite over adjacent. This is 2. And then you can find the hypotenuse by the Pythagorean theorem, which is going to be 3, 4 take and 10, 7. This is going to be 7. And you can get cosine of theta by the right triangle. That's what I was going to try if this value wasn't yielding from the wheel, but it did. So we were safe. Don't worry, I'm going to explain that same method here because I cannot use my wheel on this problem because there is no numbers. There are variables this time. Look, this is maybe the most challenging questions of all this so far because we do not have a fixed number here. I wish this was 1 over 2 or root 3 over 2 or 0 or 1. It's not one of those nice values you can use the table to find out. So what am I gonna do? Same idea. As if it's an ordinary question, I'm gonna start inside out, set this into theta first, guys. Please do so. Call this theta. Okay? Are we good so far? We're starting inside, setting into theta because we are expecting an angle. Cosine inverse functions always give an angle. Call it theta. Then guess what? I'm going to compute this theta by flipping it. So this is cosine theta equals x squared minus 9 over x. Now please, let's be smart here. Now what did I do? I called this whole blue box, look, it's here, that blue box, right? I moved it here. I called it red theta. This is not theta, right? Now what is this guy asking us? Write the given expression as an algebraic expression. Blah, 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 the rest. It says, kind of simplify. Compute this as much as possible. Algebraic expression means you won't be able to simplify this to numerical data like 1 over 2 or 3 over 2. It will involve x's in your answer. They are expecting an answer, simplified answer, cotangent, cosine, gone, but some x's can show up. When I call this theta, they actually expect us to compute cotangent theta now. Look, when I call this blue box only theta, they want us to find out cotangent theta. Agree? Agree? And what do we have in our hand? This is what we have. You know, we know cosine of theta. They want cotangent of theta. Do you see the relation? How can I get cotangent theta from cosine theta? There are several options you can go with. Actually, two. One is, okay, I want you to give me that one of them. Once you know cosine, this is way back, section 5.1 or 2. When I give you a sine or cosine, and I ask is tangent, cotangent, or any other trig function, how do you guys find it? Now, this is a good thinking question. This is a really upper level question. We're no longer just crunching numbers. Let me simplify the question. If I give you cosine theta, let's say 1 over 2, how do you guys find any other value like cotangent theta, sine theta, tangent theta? Way back in section 5.1 or secant. What do you use? Back to Future. Way back, it's been a while. Maybe we have also already done it somewhere here as well. It's somewhere. Look, they have given us tangent. We found sine and cosine back then, kind of related. They have given us cosine, and they found all other trig functions. No, not all other, sine and tangent. What did we use, guys? Trig identities, like to find cosine. If you know cosine, to get sine, you use this Pythagorean identity. If you know secant and want to find that tangent, you use this. If you want to find secant, you know cosine, you use this. Remember those? That's one option. If you know your trig identities, relations between sine, cosine, secant, tangent, you can use that. That's one option. I'll give you another one. You can go with either one, but I want you to know both. So if you know cosine now, how can I get cotangent? The cotangent is actually cosine over sine. You know cosine. You need to get sine. You can get sine here from this way. So if you substitute this one here, I'm not gonna do this entirely because this is long. You can substitute here and pull sine from 1 by subtracting 1. This is, and then once you get sine, substitute in here. Okay? Or even better, here is what you can do. Put a triangle. If you don't want to do trig identity, it's too long. Put somewhere theta, like here. Use the meaning of cosine theta. Cosine theta means adjacent over hypotenuse, correct? So I put this adjacent side, then this one will be hypotenuse. Agree? So why don't we do that? X squared minus 9 is adjacent side. Hypotenuse is x. What do they want? They want cotangent theta, right? What's the meaning of cotangent theta in a right triangle? It's cotangent is, what is it? Opposite over hypotenuse? Opposite adjacent? Adjacent opposite? Adjacent hypotenuse? Which one? Yeah, this is adjacent over opposite. Do we know the adjacent one? Yep, I do. That's root x squared minus 9. Do I know the opposite? Do I know it? I don't. I don't know it. So how can I get this opposite one? How? Yeah, use Pythagorean theorem. Square of the unknown side, square of the adjacent side makes the square of the hypotenuse. You're pretty much doing the part I didn't do earlier, like sine square plus cosine square. Look, sine square plus cosine square equal 1, kind of similar. They're kind of paying off the same bill, but I find this slightly easier because these are canceling. So you have x squared minus 9. And I need to get these guys to the other side, so I will add opposite of those to the both sides. These two cancel, by the way. Right? And question square is, we have nothing but only question mark square equals 9. What is the question mark side? Is 3. Okay, now we have the question mark 3. We have the answer, x squared minus 9 over 3. Does it make sense? Are we good? Take a peek at the next one. Before going to this is a good one actually. I want to show you a third option. We mentioned these trig identities, but maybe we didn't mention this. What was this one? This was secant square, right? How about this one? 1 plus cotangent theta square is, what is this one? cosecant square theta. Or better, this is 1 over cosine, right? No, secant, sine. Yeah. Okay, still not easier. I was hoping this one is gonna be easy, but not much. Why? Because this was saying cotangent theta, right? This is asked. They are asking for this. If you know sine theta, you can get it. But what we know here is cosine theta equals root x squared minus 9 over x. You still need to employ this fact to get sine theta. Sine squared theta is 1 minus cosine squared theta. Take square root of both sides. Sine theta is square root 1 minus this thing. And then you need to flip and square it. No, I was thinking it's shorter. It didn't. It wasn't shorter. So if you wish, you can continue and do this way, but it's gonna be a lot of squaring and thing. Best option is against construct your right triangle. Okay. Again, call this theta. This side turned into x squared minus 9. This is x. We found this one 3 by Pythagorean identity, and cotangent theta is 3 over this. That's it. Or no, square root over 3. Alright, how do you type this in again? You need to first start with the ratio and x squared minus 3 divided by 3. That was it.
Minus 9.
Thank you. Still wrong.
That's for sure.
Oh yeah. Alright, we have a couple more questions left, but from now on it's smooth sailing because we're done with the basic 3 inverse trig functions, the ones most often used. There are 3 more, you may say, where is secant, cosecant, cotangent. They are not as much as used as before, the other ones, but it's the same deal. Same kind of deal. You just need to pay attention for what angles it's valid for. Secant is the same as cosine. Cotangent is the same as cosine again. And cosecant is the same as sine. Almost the same as sine. We will mention this tomorrow. Okay.